When scientists discuss their data, they often use terms such as accurate and precise. So I just wanted to make sure that we're all on the same page with those terms. Now, before I get into the accuracy and precision of data sets, I want to clarify that a measurement can be precise as well. So if we have a measurement, for example, of 6.5 meters, that is less precise than a measurement of 6.46 meters, which of course is less precise than a measurement of 6.4603 meters, and so on. So the more decimal places you have, the more precise your measurement. So what I want to talk about now is not with regard to specific measurements, but more data sets. So if you're looking at a number of measurements, how do we summarize the data as accurate or precise? This is often discussed in terms of a bullseye, like for an archer or a sharpshooter. Yes, we did talk about this in class. So if we have a bullseye, the center or bullseye is considered the actual or true value. So sometimes that is known and sometimes it's not known. So in an experiment, if you conduct an experiment, sometimes you know what you should get or need to get based on the laws of nature, but sometimes you don't know. So we can't always think in terms of this model, only when the true value is known. So let's say we take some measurements in an experiment and a measurement is lower than the actual or true value, and another measurement, we take a second measurement and it's also a little low, and a third measurement is also low, and maybe a fourth measurement is low, and a fifth measurement is low. These measurements do have pretty good reproducibility. They're all clustered in the same area of the target, but they are all lower than the actual or true value. So in this case, we might consider our data to be precise because the data is pretty reproducible, but not all that accurate because we fall below the bullseye almost every time. Let's do another distribution of data. Let's say that we collect a measurement and we are a bit high, and then we take a second measurement and now we're a little low, and then a third measurement, maybe we're actually right on the money. Fourth measurement, again we're high. Fifth measurement, we're a little high. Sixth and seventh measurements, we're low. In this case, our data is not precise because our measurements are kind of all over the place. They're not reproducible. So this distribution would not be precise, but it would be pretty accurate because if we were to average these three data points and these three data points, we would see that the average of those 6 data points would fall right around the bullseye. So the data set's average, again, considering that none of them are outliers, the average would fall right around the actual or true or known value. So that distribution is not precise but accurate. And we can do one more here. Let's consider the blue data here. What if data is clustered right around the bullseye? So we take measurements, and our measurements are all very close to each other, so good reproducibility, and the measurements are clustered around the true or actual value. In that case, we would have the blue data would be accurate and precise.